Welcome! In this series of short videos, we will look at topics common to both the PowerBasic Console and Windows compilers. Today we will look again at how to use linked list collections within your applications. Linked lists are one of 3 different types of collections that PowerBasic supports internally. A collection object is a set of items, which can be referred to as a unit. It provides a convenient way to refer to a related group of items as a single object. Today we're going to be looking at the linked list. So how can we use a linked list in your application? First of all, we need to define the class. This can be done quite easily with 2 lines of code. So let's go into our PB main function and set this up. Here we have declared a local variable called listCollect, and we're defining it as one of the inbuilt commands in PowerBasic, the I linked list collection. We're then taking that listConnect variable and we're defining it as this class. This has now set up a local variable as a list collection. So now that we have that set up, we can quite easily use the methods within this class to determine how many records we have within this collection. So we're going to use our inbuilt logging command to log to the console the number of items within this collection, using the count method. listCollect count returns a number, so we're reformatting that as a string so we can use our logging function. So if we run the application now, it will compile, run, and tell us that the item count within our linked list collection is 0 in size. This is because we haven't added anything to the collection just yet. So let's create a little function to add some data. So we're going to use a new function called addStringData, and we're passing as a parameter the name of our collection, listCollect. So let's go and create this new function. So here is the skeleton of our new function taking its single parameter. And we're defining that as an I linked list collection. So we'll put a message out to the log to say we're going to be adding some strings, just for documentation purposes. In order to add to our collection, we can use the add method. I'm going to use the prefix command here to save a little bit of typing. The prefix command prefixes what appears in quotes after it with each of the subsequent lines. So at compile time, it will compile to listCollect.add, and in brackets and quotes, the string we're going to be adding in this case. So we're adding 4 separate strings to our collection, and then ending the prefix. So to confirm we have actually added 4 items to our collection, let's use the item count once more. And if we try running the application now, we can see we're adding the strings and the item count has now gone up to 4. So this is confirmation that our strings have indeed been added. So how can we pull the information back from this collection so we can see the data that actually exists within it? Well, we can do this quite easily. We're going to declare a local variable to contain our output items, and we'll call that item output. It's declared as a variant to allow it to contain any type of information. At this point, our application may not know how many items sit within the collection, but we're going to use a for each command in here to pull each bit of information back individually. So we will first output a blank line and then use the for each command to look at our list collection, and it will populate this variable we have just declared. And then we can use our logging command to use the variant $ to turn this content here in this variable into a string that we can display on screen. So if we run the application now, we will see there are the 4 pieces of information we placed within the collection, the 4 names. As we're going to be using this type of code quite a lot, we can define this in a macro to save us a little bit of work. So we will cut these lines of code out of our current code and put that into a macro. And here is the macro defined at the top of our code. I'm prefixing the macro name with the letter M, just so it indicates to me as the programmer that we're going to be using a macro. And this parameter here for macros is to pull the information in. When PowerBasic compiles your application, it takes all the code within the macro block and places it within the body of the main code before compilation. And we're using this v-item output as a macro temporary variable. This allows it to be defined in here, and each time this is inserted into the code, it will increment the number of this variable, which means you won't have collisions with existing variable names. The rest of the code is as we had before. So if we now take this line of code and put this into our pbmain function, this makes the typing within our pbmain much more concise. So if we run the application now, we will get exactly the same result. The 4 items within our current collection are displayed on screen. So now that we've added to our collection, there may become a time when you want to clean out the collection and start again. There is another method called clear, which can be used to do this quite happily. The name of the collection, followed by the word clear, will clean out all data within that collection. We can then use our listCollectCount method to determine what's left in the collection. So if we run the application once more, we can see in the collection here are the 4 items. And after we've cleared, the count goes back to 0. So we've added to the collection and we've also cleaned it out. We can then re-add the data by running these 2 functions once more. So this would put the data back into the collection, adding the string data first, and then displaying all the items in the collection. If we run that once more, we will see there is the data being cleaned out, and there are the items being re-added, and there are our items being displayed. So we have control of what goes in and out of our collection. What if we need to delete a specific item? There is also a remove method, allowing you to delete an item by its index position in the collection. So let's say we wish to delete the second item in the collection. We specify the index number, followed by the remove method. It takes a single parameter, which is the index pointer. And again, we can display all the items in the collection to see if our removal has been successful. Since this index is a new variable, we will declare it at the top of our code as a long. If we run the application now, we can see there is the data sitting at that point with 4 names, and the second name on the list has now been removed. So we're now down to 3 items of data sitting in the collection. So as well as storing string information within this collection, we can also store other types of variables. And next, we're going to add an array to our existing collection, which has 3 items in it already. So this will be the 4th item. So let's prepare to add our new array to our collection. First, we're going to declare a variant to hold the input data. Next, we're going to dimension an array and assign some data to it. So there is our new array, consisting of a single dimension array from element 0 to element 2. So it has 3 elements. And we're assigning to that array the values A1, B1, and C1. So this is a string array. We can then put that string array into our variant variable by using a let command. And as we did before, we're going to use the add method to add this variant to our collection in a single line of code. And once more, we want to display the data. However, what we're getting back out of this collection are 2 different types of variable. So we'll need to modify the macro we have that currently displays the data. So we're going to create a second macro. and this will handle extended information. So at the top of our code, we're going to create a new macro. This is going to be slightly more complex because it's going to be handling, eventually, 3 different types of information within the collection. We already have strings within the collection. We're going to be adding arrays next. And finally, in the last part of this code, we're going to be handling user-defined types. So in this macro, we are dimensioning an array. We're also using the variable for our output as a variant, and we're also defining a user-defined type. I'll define this type at the beginning of our code in a moment, but let's push on with this code here. So as we did before, we're going to be using a for each command to step through each element within this collection. One thing we'll need to do within this loop is to determine what kind of information is held in this variant variable. PowerBasic gives us a way of actually doing this by providing this command. If we hit the F1 on this command, we'll see that this function allows us to determine the internal data type of the data stored within a variant variable. And we can do this by looking at these equates. Specifically, this one for looking for a dynamic string, and this one for looking at arrays. So let's put that coding into our application. So first of all, we're going to be testing to see whether what we're looking at is a string and also an array. So we're going to populate our local array with the data that's come back in this variant. In this case, we know it's going to be 3 elements in an array. Of course, it could be 30 or 300. So we'll do this in a try-catch block. So first of all, we will use the let command to populate the array with what's in our variant variable. And then, having populated the array, we're going to step through the array 1 element at a time using a for next loop, from the lower bounding to the upper bounding of the array. And we'll push that information out to our log just so we can see it. So this should handle normal arrays. So how do we handle strings? Well, this is done in another case statement where we're looking for just this constant. And initially, we'll just treat this as an ordinary string. We'll come back later and make some more changes for user-defined types. So before we do a compilation on this, let's go to the top of our code and create the user-defined type we'll be using shortly. And here is our user-defined type. It's going to be holding 3 types of information: a name, an account, and a balance in currency format. So let's try a quick compile to make sure our code compiles cleanly, and we'll attempt to run. So at the bottom of the screen, we have the information sitting in the collection at the end of the application. We have the 3 pieces of text. And following that, we have 3 additional rows. This is the information coming out of the 4th item in the collection, which is a 3-element array. So we have successfully added both strings and a string array to our collection. So let's now prepare a user-defined type and see if we can add this to the collection as well. So here we are populating our user-defined type, with again using the prefix command to save a little bit of typing. So the first element, name, is going to contain the string main account. The account element is going to contain a string as well, and the final element, the balance, is going to contain a currency value. So having populated the user-defined type, can we now put this into the collection? And again, this is remarkably easy by using the add method and defining our parameter as UData, the name of our user-defined type, and followed by the words as string. So we're treating the data within the user-defined type as one big string. And we will also display the collection onto our log. However, our macro is not currently handling user-defined types. So before we run our application, we'll want to define the user-defined type. And at the beginning of our code in this function, we'll put in a definition of UData as UDT data. So before we can actually display this user-defined type correctly, we'll need to put a little bit more code into our macro. If we ran the application as it stands, we'll see the data coming out at the end of our collection is not displaying correctly. This is because our macro is not handling user-defined types correctly and treating them just as basic strings. So let's go back to the code and amend that macro once more. So we can see that the first character in what comes back is a question mark. So we'll take advantage of that and test for it. So if the left of the variant turned into a string is going to be a question mark, then we'll assume it's a user-defined type. Otherwise, we will treat it just as an ordinary string. So how do we handle user-defined type data? Well, we can use a single line of code to convert that into our user-defined type. And that is using the typeset command, followed by the name of our user-defined type and the variant $. And this is handling information in that variant as 1 byte at a time. And this turns it into something we can actually use. Then we can push that information out to our log by defining the user-defined type, a dot, and the element name. So we're getting the account name, the account number, and our balance converted from currency into a string. And we're using the second part of the format command to ensure we get the 2 decimal places. And if we attempt to run that now, we will see at the bottom of the data coming out of the collection, we're getting the details that come out of our user-defined type: main account, account number, and balance. So of course we can also print out the number of items sitting within our current collection. So there are other commands we can use to manipulate what's in this collection. Ideally, the list link collection is really useful where you wish to put things into a to-do list and record them in the order that they come in. That way you can step through your list, and as you process each one, you can remove it from the collection. However, there may be times when you want to move around this collection using other methods. So we can get the first item by using listConnect first. This sets our index pointer to the first item on the list. At any point in time, you can get what the current index happens to be by using the index method. In this case, since we're pointing towards the first item, this index variable will contain the value 1. So if we declare another local variant, we can then get the data. And this can be done quite easily by using the item method. So vitem would be populated using the listCollectItem method. It takes as its parameter the index we're interested in, which we have just populated to be the first item on the list. We can then push that data out to our log by converting it to an ordinary string. So if we run that now, we will see the first item on the list is the word Daniel. And we can see that is indeed the first item on our collection. So what if we wanted to replace the data within that very first item with some other string? Well, there is also a replace method. It takes 2 parameters, the first parameter being the index we're interested in. The second parameter can either be a string or a variant variable. This will contain the data that we wish to replace into our collection, taking out what was there originally. So if we put this in place and display our whole collection once more, and if we run the application now, we will see there was the first item, which was Daniel, and following the replacement, it's now been replaced by the string Michael. And all the other data is still in place. So how about inserting a new piece of information somewhere into the list? So this can again be done quite easily. We'll set our index to the number 2. So we want to insert a new data after the first item and before the second. All the other items will be pushed down one slot. And again, this takes 2 parameters, the index number, which in this case is going to be 2, and the data we wish to insert. And of course, once more, we will redisplay the entire collection. And if we run the application now, we can see there is our text being inserted in the second slot, and all the data that was in there has been moved down. So in summary, what we've done today is create a linked list collection. We have put 3 different types of data into this collection: basic small strings, arrays, and also a user-defined type. We can determine quite easily what's coming back from the collection by using the code we placed in our display list macro. This allows us considerable flexibility in handling data into and out of these types of collections. Hopefully you'll find this code and these methods useful in your applications, but that's it for today. Thank you for watching.
Thank you for watching today's video. Please feel free to click on the link in the description below to discover more videos.